Welcome. This is going to be our lecture video for May 5th. Let's go ahead and get started. Here we've got a triangle given two side lengths in the non-included angle. So we don't have the angle in between the two side lengths. Can we still find the area? So you might originally say, no, we need two side lengths and the included angle. We need this angle in here to be able to find the area. So this is impossible because we don't know this one either. But actually you can. And the trick is we need to find this angle over here using law of sines and then the triangle sum postulate, and then we can use our area of a triangle formula. So if we look, we have an angle in the opposite side. So that's enough information to set up another relationship between an angle and an opposite side to find that angle. So the sine, well, let's see, we're solving for an angle, so we want the sine to be on top. Make that better. So the sine of 115 over its opposite side of 15.1 is equal to the sine of unknown angle x over its opposite side of 11. All right, multiply both sides by 11. Plug this into your calculator. This angle is given in degrees, so make sure your calculator's in degree mode when you do sine of 115 divided by 15.1. And I'm going to multiply that by 11. And I get 0.66 equals the sine of x. Now with that number still in your calculator, just do inverse sine of second answer. And we get x equals 41.3 degrees. So if this angle here is 41.3 and the three interior angles of a triangle must add up to be 180, so I'll say angle 1 plus angle 2 plus angle 3 must equal 180, then I can solve for this last angle because 115 plus 41.3 plus z equals 180. I'll do 180 minus 115 minus, still got that number in my calculator, so I get angle z equals 23.7 degrees. So now I know this is 21.7 degrees. Now I've got two sides and the included angle, so I can use my area of a triangle formula. So it's it's similar to 1/2 base times height. But we say it is AB sine C, where these are two side lengths and this is the included angle. So I don't really even worry about labeling it. These are two side lengths. This is the angle in between them. 1/2 11 times 15.1 times the sine of 23.7 degrees. So I've still got the number in my calculator, so I'll take the sine of that number, multiply it by 11 times 15.1 times 0.5. And yet the area here is 33.36 kilometers squared. Okay. Goal today is to learn the law of cosines and then solve triangles given any three pieces of information. Why are we doing this? If you don't have an angle and the opposite side length, you can use law of sines. I think I meant law of cosines here, because if you did have an angle on the opposite side length, then you can use law of sines. If you don't, you use law of cosines. Okay, it'll make more sense in a second. Get this copy down in your notes. Also, hopefully the date's in there. Here's the first law of cosines. Can you figure out the other two? So a squared equals b squared plus c squared. That's just that comes from the Pythagorean theorem. And then you get the minus 2bc cosine a. So let's see if we can figure out what it would be for b squared. B squared equals a squared plus c squared minus 2ac cosine b. So everything just kind of switches places. And if we're solving for c squared, you get b squared, or let's start with a squared. A squared plus b squared minus 2ab cosine big C. Notice this is an angle. These are side lengths. So this is when you've got, essentially you've got three pieces of information, but you can't use law of sines. So we'll see it works in this situation here. Notice we don't have an angle and the opposite side length. Everything is missing. We would be able to find the area of this triangle. We've got two sides and the included angle, but that's not what we're trying to find. We're trying to find a length. So we just need to label this up. I'll pick this to be side length A, this will be side length B, this will be now side length C. This will be angle big C because it's opposite of little c. This will be angle big B, this will be angle big A. So now we pick the formula that has big C in it. And so that is c squared equals a squared plus b squared minus 2ab cosine big C. And now we got to fill in what we've got. So c, we can replace it with the x or just leave it as a c. I think it'd be fine either way. So 11 squared plus 7 squared minus 2 times 11 times 7 times the cosine of 50 degrees. And this all can be plugged into our calculator. You can even plug it in one line. Just don't forget to then take the square root. So I'm going to do that. 11 squared plus 7 squared minus 2 times 11 times 7 times cosine of 50. I'm still in degree mode. I get that x squared equals 71 point something. Square root, x equals second square root, second answer, 8.43 units, rounded. And then you just look at the triangle. Does that look like it's about 8.3? Yeah, close enough. Maybe this isn't drawn perfectly to scale. So it looks like it might be a little bit longer than that if this is only 7 here. But my guess is this triangle just isn't drawn super well to scale. Maybe, that's not really 50 degrees. But yeah, close enough that I think we can move on. All right, here, can we use law of cosines when we just have 3 side lengths? We can, it's just a little bit more tricky. So label up the side lengths. I'll have this be A, this be B, this be C. This will be capital C here. We're trying to find capital C. So we'll use that same formula. C squared equals A squared plus B squared minus 2AB cosine C. And let's just fill in everything that we got. 8 squared equals 6 squared plus 5 squared minus 2 times 6 times 5 times the cosine of unknown angle x. All right, 64 equals 36 plus 25 minus 60 cosine x. 64 equals 61 minus 60 cosine x. And I cannot tell you how many students, even this late in the semester, I see make a big algebraic mistake by combining the 61 and the 60. Often these numbers are close together and it just feels like, yeah, these should be combined, but that's not how algebra works. This is 60 times cosine x. We can't just combine these. You got to subtract the 61 over. For some reason, like the way this is set up just makes everybody want to just completely forget about the order you're supposed to solve equations in and just combine those to be a 1. But yeah, just a really common mistake for whatever reason. Just looks like that's how that should work. Probably just because the numbers are close, but now we've got negative 0.5 equals cosine of x. take the inverse cosine, check what mode you're in, because that's what mode or what unit you're going to get your answer in. And I get 92.8. We'll do 92.9 degrees. And look back at the picture. Could that be a little bit over 90? Well, it doesn't look like it right now. Actually, is that the exact same triangle? Really similar. But, it's, this is just a sketch. Could that angle be a little bit more than 90? Yeah, easily. If we kind of squish this down a little bit, it would be more than 90. So yeah, just make sure that the number makes sense, that you don't get a number like 0.2, because that's not going to be an angle. All right, so what does it mean to solve a triangle? If you were told to solve a triangle, this is what you're expected to do. Find all 3 side lengths and all 3 angles. That's what it means to solve a triangle. So here we've got a triangle. We need to solve it. So we need to label everything that's missing here, including this angle here and these 2 side lengths. So it looks like we can just do law of sines to figure that out. So I'll set up my relationship with the fact that the 12 is opposite of the 38. So sine of 38 over 12 equals sine of A over, well, that doesn't work because I don't have this A over here. So I guess we'll find B first. Although if I'm finding a side length, I'm going to want to flip these upside down. So 12 over sine of 38 equals B over sine of 85. So sine of 85 times 12 divided by sine of 38. It gives me that B is 19.4. But now we can't do law of sines because we don't have one of the 2 opposite pieces of information. So we've got to do law of cosines to find one of these. Then we could do, oh wait, actually, making all sorts of mistakes. We can just do the triangle sum postulate. 180 minus 85 minus 38. That'll give us angle A. Then we can do law of sines. Not that law of cosines would have been wrong, but it does take a little bit longer. So that gives me that this angle here is 57. Now I can do law of sines, and I'll do 12 over sine of 38 again equals A over sine of 57. 12 over sine of 38 times sine of 57. We get that this length over here is 16.34 units. Little degree marker there. Okay, so this triangle is solved. We have all of the information. Here's a useful table that tells you when to use law of sines versus law of cosines. Maybe pause it, write it down if you think that'd be useful. Okay, last thing, the ambiguous case. So this is a triangle with 3 pieces of information, but just because it has these 3 pieces of information doesn't mean we can solve for everything else. This is the one scenario where we get 2 different possible answers. So let's try to draw this triangle. So angle C is 33 degrees. So 33 degrees, that's maybe a little too steep, shallow. That's about right. So that's 33 degrees right there for angle C. We'll pick these sides to arbitrarily be A and B. B is 10 inches and C is 6 inches. Okay, we can do law of sines here to find angle B. So sine of 33 over 6 equals sine of B over 10. Simple enough. Multiply 10 to both sides. So 10 times the sine of 33 divided by 6, we get 0.9 equals sine of b. We would then just take inverse sine of both sides, but here's where we get our two answers. When I ask inverse sine of 0.9, I could say, what's the inverse sine of 9 over 10, right? That's still equal to 0.9. I can even draw that as opposite over hypotenuse. And we know that with sine, you get an answer in the first quadrant and in the second quadrant. So 9 over 10, 9 over 10. Now normally when solving this, you'll get one answer that makes sense and one answer that doesn't make sense. You'll just go with the answer that makes sense. But actually both of these will make this triangle work. So angle B could be what our calculator gives us. Let's do inverse sine of this number. And we get 65 degrees. But I could do 180 minus that and get that this angle all the way out to here is 114 degrees. Normally we would get rid of this answer, and so we haven't even been talking about it. But if we look here, 114 degrees and 65 degrees both work. They represent either a triangle that looks like this or a triangle that looks like this, where this angle is either 65 or 114. And if we think about what's fixed here, this angle is fixed, this side length is fixed, this side length is fixed, this angle isn't fixed. So what's happening is that this side can either intersect here or it can swing around and intersect here and still make a valid triangle. So we don't get infinite solutions, we get two different distinct triangles that can happen. Here, I think, yeah, here's a better picture of how we could do that 6 inches to still hit this side length and still make it 33 degrees, without changing any of the lengths that were given. So that's the ambiguous case. Don't stress it too much. Normally just one triangle is enough, but be aware that sometimes with a very specific setup, you can get two valid triangles. All right, on the calendar, there's this map problem that I think is pretty fun, where you're connecting cities across America. You can practice your capitals. It's not collected for credit, but I think it's a good assignment. You should do it. And there's a homework to work on that, and have a good rest of your day.